Does anybody remember from last Friday how we convert rectangular to polar? Or better than that, let's start here. What am I talking about when I'm comparing rectangular and polar points? What does a rectangular point look like? What's the form we typically put it in? What's that? That's how we graph it, but what form would I put a coordinate point or an ordered pair in typically? What letters do I use to describe x and y? Yeah. So my rectangular point is x comma y. And then if I want to convert that to a polar, what do I need to find? What's that? Yep, the radius, which they define as r, and the radius is, where x, y is like they call it rectangular because I move left or right and then up or down. I have these real sort of square right angle moves, whereas a polar gives me a radius, how far out am I going, and then I move around and find my place by seeing how much I'm opening up. And so what's the other piece of information that I need here? Theta, some angle measure. Yep, so we define that as theta. And then we actually figured out on our own how to find both r and theta. R is found by doing what? Might have to look back, but it was based off of the Pythagorean theorem. Beautiful job. Square root of x squared plus y squared. And theta is found by using x and y as well, and SOHCAHTOA, or some trig functions. And so I didn't set up a theta equals, but I did make a statement about theta, and the tangent of theta can be found by taking y over x. And so we have to figure out when the tangent is equal to that. And we also talked about the fact that the problems that we're going to be dealing with are going to be dealing with the families that we've already known. So when I'm trying to figure out when the angle is going to happen, I shouldn't need my calculator at all. I just need to think back at all of the families and the axes that we talked about. And so let's refresh our memories, see if we can get this going from last week. Number one, I can tell theta immediately. I know what theta is. I don't have to do any math. What is theta and how do I know? Three pi over 2. Are you magic? How do we know that? It has to do with the unit circle. If I plot this point on a rectangular grid, I am right here. That's an XY coordinate. And if I were to superimpose the unit circle over the top of this point would line up perfectly with 3 pi over 2. Now I just have to figure out my radius. And so this is where I'll do my x squared plus y squared. So my radius is the square root of 0 squared plus negative 2 squared, or the square root of 0 plus 4, or the square root of 4, or 2. If it's on an axis, it can be that simple. We just have to figure out what position on the axis, on the x-axis or on the y-axis, that this angle is most associated with, or this point is associated with. When it is not on an axis, that means it's going to be in any one of our families. Pi over 3, pi over 4, pi over 6. And you should be able to tell by looking at the point which family we are associated with right off the bat. Which family are we associated with here? Anybody got something?
Pi
Pi over 4. Anybody think differently? Agree? What's in there? What interesting thing is in there? Or maybe not interesting, maybe it makes you sick to look at it. What's in there that stands out? The square root of 3. So when I think about these families, which you guys have memorized right now, I am interested in the one that has the square root of 3 in the y position. And that's this guy. So I know I'm in the right family here. How do I figure out which quadrant? Just look back at my point. Where am I? Quadrant 3. So I'm looking for the quadrant 3 pi over 3 family. Quadrant 3 pi over 3 is what? Beautiful. Done with that, I found my angle. Now I need to find my radius. Oops, square root of -2 squared plus -2 times the square root of 3 squared. Bless you. That is 4 plus, remember, square the -2, 4. Square the square root of 3, 3. 4 times 3, 12. Gives me the square root of 16, or 4. So this tells me to get to the point -2 square roots of 3, I would draw a radius out 4, and I would move it around to 4 pi over 3, and they would land in the exact same spot. So rectangular to polar, not so bad. Now I want to convert polar to rectangular. What if I'm given a polar coordinate and I want to figure out the rectangular coordinate? Well, we're going to go back to kind of a little picture. And so I want to start by drawing just a regular old coordinate plane. And I am going to go ahead and pick a point out here. If I am given polar coordinate, this is r comma theta, right? And so what that tells me, if I draw a right triangle, just like we did on Friday when we were trying to figure out the rectangular to polar, if I draw a right triangle, what pieces of information do I know on this triangle? What does r theta give me? The hypotenuse and the angle on the inside. Beautiful. Excellent. So I want to take that r and that theta, that hypotenuse and that angle on the inside, and I want to use that to find x and y. X and y don't change. It's still that left and right move, or right and left move, and up and down move for y. And so again, I'm going to go back into my trig days and I'm going to do some SOHCAHTOA stuff. I'll start with x. Let's put x in terms of theta and r. So I'm going to ignore y. If I think again about SOHCAHTOA, I have an opposite side, I have a hypotenuse, I have an adjacent side. I'm ignoring y. What two pieces of information do I have? Which trig function? Cosine. So the cosine of theta is equal to the adjacent over the hypotenuse. Good? How do I get x alone? Multiply by r times r times r. So r cosine theta will give me x. Done. Figured out my conversion. Let's do the same for y. Ignore the x. I've got opposite and hypotenuse. Which trig function will I use? The sine of theta is y over r. Same move as last time. And I've got my y. So when I'm converting to a coordinate point, r cosine theta will be x. R sine theta will be y. And again, going back into like chapter 2 and trying to figure out what these values are. For number 3, I'm going to figure out x. X is r cosine theta. So x is 2 times the cosine of pi over 3. Bless you. So x is 2. What is the cosine of pi over 3? 1/2, beautiful. So 2 times 1/2. So x is 1. There I have my x coordinate. Y is r sine theta. 2 times the sine of pi over 3. What's the sine of pi over 3? Square root of 3 over 2. And so y is, cancel, cancel, square root of 3. Of course, we're going to move into other quadrants. And if you remember all the things that we've talked about, your answers should be able to, like, visually make sense. So I'm looking at the pi over 6 family in problem number 3. And in fact, 11 pi over 6 puts me in what quadrant? The fourth quadrant. And in the fourth quadrant, the x-coordinate is positive and the y-coordinate is negative. So when I work through this problem, my x-y coordinate better be a positive negative point. And it will work out that way if we do our trig correctly. So I'm going to go ahead again and do the same thing that I did on this last one. I'm going to find my x. That is 3 times the cosine of 11 pi over 6. And I remember these, actually remember x is very closely related to the cosine. When we were doing our coordinate points, we found our cosine by looking at the x-coordinate, our sine by looking at the y-coordinate. So it should make sense that the x-coordinate is found by using the cosine. So I need x to be 3 times the cosine of 11 pi over 6. Again, 11 pi over 6, fourth quadrant. Fourth quadrant, pi over 6 family. Pi over 6 is square root of 3 over 2, 1/2. Fourth quadrant makes it positive and negative. So x is 3 times the square root of 3 over 2. Can't do much with that. It is 3 times the square root of 3 over 2 is how I'm going to leave it. I can't cancel anything. All I can kind of do is multiply the top number, 3 times the square root of 3, and then the 2 on the bottom, because remember this is 3 over 1, blah, blah, blah. So I've got my x-coordinate. 3 times the square root of 3 over 2, and I'll go through and do the same process to find my y. Y is 3 sine 11 pi over 6. So that is 3 times negative 1/2, or negative 3/2. Done with my point. want you to try problem number 5. And before you go into it, I want you to think about a couple of things. Think about what your XY coordinates signs should be, just by where the angle lands. And also think about how X and Y should look. So take a few moments, do number 5, and then we'll talk about number 6. All right, I got mine up. Hopefully you got a good start. I hope I didn't go too quick on that. But when you were thinking about it, I'm hoping your mind went in the direction of. I know this is the third quadrant, so both my X and Y better be negative. I know this is a pi over 4 family, so I know my X and Y better look the same. Their signs might be different, but the pi over 4 family has an X and a Y value that are the same. Let's move on to the axis now. And so the axes work the same. And you can go through that process of X equals 2 times the cosine of pi, and Y equals 2 times the sine of pi. You can also kind of take a look at where we are. So if I think about that position, I know that is a negative X value, 0 Y value. So I know for a fact I'm going to have a negative X value and a 0 Y value just because the angle pi. So when I set this up and start to work myself through this, this is 2 times negative 1, oops, or negative 2, and this is 2 times 0, or 0. And again, I can just fill in that spot. So the position of those angles is very important. And speaking of the position, our next move is going to be to graph them. Now we're going to talk about also the potential for a negative radius. And it has to do with movement when we graph them. So far, when we've done our values, we have always only had a positive R. But there can be a negative R, okay? So any questions on converting? How does that feel so far? Okay-ish? Good. Okay. So let's go ahead and graph. I sort of mentioned about the graphing a little bit. Remember that an XY coordinate is a very rectangular, that's why they call it that. I move either left or right, and then I move up or down. It's very squared off, 90 degree, where this is, polars are very circular, okay? And so we're moving out. It's going to give me 2 pieces of information, a radius and an angle measure. So when I know it's in polar coordinates, I know that the second coordinate is always something to do with pi, and so that is actually 0 pi. Even though it doesn't say it, it is 0 pi. And so to graph that, I move out 3, and I don't move 0, or I don't move an angle at all. I stay at 0 pi. when we were graphing in the past, like way back when, back in chapter 2, back in third term, at the start, a negative in front of the angle did what? Made it move the other way. And it still works that way. So this says move right 2. And then move backwards 3 pi over 2. So I'm going to move right 2. And then I'm going to move backwards half pi, a whole pi, 1.5 pi. And there's my coordinate. I don't even have to know the family to know how far I move. I just have to know the quadrant in which I land. And so for my next one, I am moving a radius of 4, and I'm moving 19 pi over 12. Well, 19 pi over 12 is 1 7/12 pi. So that's 1 and a little more than half pi, just like when we were graphing our angles. Same thing, only difference is I'm moving out 4. Moving out 4. And then moving 1 pi and a little bit more than a half. I'll put it right there. I'm not going to measure where your things are, so don't worry too much about that. If it's on a graph, approximate. It's not 5 pi over 3, it's just a little bit more, so I'll put it before 5 pi over 3. Let's talk about that negative radius. All the negative radius does is instead of me moving out to the right, I move out to the left. But I still go the same way. So this one says, move left 3, and then from there, move backwards 1 1/4 pi. Backwards. So move, that says left 3. So from the origin, left 3, backwards 1 pi, and 1/4 pi more. That's right smack dab in the middle. That's the only thing a negative will do. And we're going to practice working with negatives, converting to negatives, because in the past we've known that I can get to the same position on the unit circle just by wrapping around 2 pi, wrapping around 2 pi. Same thing when I'm dealing with polar coordinates. I can get to the same spot by moving left or right or forward or backwards. What's wrong? Left 3, 1 pi, and 1/4 pi more. Why what? Because it's negative, so I have to move backwards. Good? Yeah, yeah. So I have to follow the directions on both pieces of those. This doesn't, the weird thing to me about polar coordinates is it can get a little confusing. Like negative, negative to me always means third quadrant. Negative, negative means third quadrant. That's in coordinate, or rectangular coordinates, not in polar. It's all about direction. That negative means a backwards move as opposed to our normal forward move, okay? So I want to practice moving around, and we're going to get to the same position, same point, this point right here, by moving different directions, okay? So I'm going to start by plotting this point. This is 2 13/12. So 2 13/12 is 1 1/12 pi. So if I'm going to plot that point, I move to the right 2, and I move 1 pi and 1/12 more. That's a little bit more. So this little measurement here is 1/12 more. That's that degree, 1 1/12. So this is one measure. I could get to that same spot by moving out 2 and moving backwards. Well, how much would I be moving backwards if I'm already 1/12 into this quadrant? 11 pi over 12 backwards. I kind of want these two things to add up to be a total of 2 pi if I were going to take the absolute value and add them. So 13 twelfths plus 11 twelfths gives me 24 twelfths. That would be the full circle, okay? So to get here, I would move 2 and 13 twelfths forward. Or, I'll do this one in orange. I could move 2 and 11 twelfths backwards. I can also do -2, meaning I start over here. How much would I have to move forward? Pi over 12? Or I can move here and move backwards. Oh boy, how much am I moving backwards? Ooh. Nice job. It's all about playing with those fractions. Again, in both my backwards moves, if I want to take the absolute value, I need these two things to be 24 pi over 12 because they're completing each other. I'm getting there moving one way or the other way to meet. And so that's kind of a way that can check your work as you go because I need both my absolute values of my positive angles to add to the right, and I need the absolute values of my negative. Oh, I should make this negative, shouldn't I? Because I moved backwards. Sorry about that. I almost missed that. Backwards, that amount. All right? Okay. So let's go and do the next one. Give it a whirl. Free your mind. Let's start by plotting it. I made it a nice family one. Radius 3, move up to pi over 3. So radius 3 up to pi over 3. I plotted my point. There I am, sitting nice in the first quadrant. This was a positive radius, positive angle. I want a positive radius and a negative angle. How far do I have to move backwards? Nice job. Excellent, excellent. Again, remember, you want these two things, the absolute value of these two things, to add up to 2 pi. Because I want, again, I want to get there from the right way and from the wrong way, but together they connect and make a complete circle. So you could just basically take 2 pi minus pi over 3, get your missing piece, and make sure that because you're going backwards, you make it negative. So let's do a negative radius. I want a negative radius. So I'm over here, and forward, how far do I have to move? It's going to be a little tricky. Sometimes I just count the quadrants and think of my families. So I'm moving through 1 quadrant, 2 quadrants, 3 quadrants. What's a third quadrant pi over 3? 4 pi over 3. Yeah. And I moved forward, so I'll keep that one positive. Okay, yeah. Yep.
Wouldn't it be 2 pi over 3 because 1 plus pi over 3?
Are you, which are you talking about? Are you talking about this one?
No.
This
if
one?
you're starting at -3.
I'm starting at -3.
Yeah, and then you go over pi, and then you add pi over 3.
Uh-huh. 1 plus pi over 3.
I do that.
Good? Yeah. Okay. All right. And so then let's do the next one. backwards, but this time I want a negative angle. Hello, Mrs. Weedon. Yeah. Oh, yeah, fine. What's up? Okay. Oh, got it. Perfect. No problem. Yep. Yeah, you bet. Bye. Okay, so how about this one? Think think position, and if it's a family especially, think about how far you're moving. So to get from -3, I'm moving through one quadrant into the second quadrant. What's the second quadrant, pi over 3? 2 pi over 3. Then I have to put all the stuff together. I'm moving forward, I'm moving backward, I'm doing all this. Hello, Mrs. Weedon. Yeah. He did. I will, absolutely. Yep, you bet. Bye. All right. How do you guys feel about that? You want to try one? By no, you mean yes? No. All right, give it a try. Give it a try. Give it a try. See how you do. So I want another positive with a negative angle. And then I want 2 negative radii, one with a positive and one with a negative. Yeah. We actually are going to have just a quiz tomorrow, just a real little quiz. It'll be on your final and it'll be on some of your homework assignments as well, but it's not going to be like a big major test. And in fact, this is it. This is all we're learning. We just have these 2. Usually we go into graphing them, but we just don't have time to do that because of the snow days. So, how do we feel about this? Questions? Anybody able to get these? Anybody want to fight me? Okay. Okay, let's do our last one, and then we're going to get into, this one actually our directions change. Okay. Let's actually follow the directions on this page, sorry. So this one says, find all pairs of polar coordinates that describe the same point as provided. Well, I just listed all the different ways I can get to that point within one lap, all right? And so what I want to do is take this information and convert it into an all solutions. Who remembers how we do all solutions? What was that funny thing we added? Plus 2 pi k. I'm going to do the same here, all right? So I want to take a positive one. I'm going to take the first positive one. My angle is 2 comma pi over 6 plus 2 pi k. That will get me around and around. So that's my first solution. 2, that's not a z, 2 comma pi over 6 plus 2 pi k. I need another solution. My other solution has to come from the negative radius. And so I'm going to take the negative radius with the positive angle and do the same thing on that one. Let the world know that k is an integer and call it a day. So when I'm listing all the angles or values or solutions that can go, I want to do one positive where I keep going around 2 pi k and one where it's negative where I keep going around plus 2 pi k. Okay, so we're going to go through that process in the next one. I've got my positive, that's 4 pi over 3, right over here. I can also get there by going negative 3 pi over 3. Good. I could also get there by going 3 and backwards, or negative 3 and backwards, but I'm going to go 3 with a positive radius, positive angle, negative radius, positive angle, and now I'm going to put it into my all solutions form. So I've got my 2 angles that I'm going to work with. I'm going to get my solution as 3 comma 4 pi over 3 plus 2 pi k. And my other solution is -3 comma pi over 3 plus 2 pi k, where k is an element of the integers. All right. So number 15, give it a try. Find your one negative solution. Put it in the right form. And when you're done, take a peek up. Also keep in mind, I am writing my solutions, my all solutions, again, with one positive radius, one negative radius, but with both positive angles. You could write them with negative angles if you wanted to as well. So there are different answers that are out there. I've also seen other people do like a variation of the 2 pi k on the positive or on the negative. But I always like to keep it simple. I keep my one positive radius, one negative radius, keep my angles positive, and always just stick with the plus 2 pi k. Again, so there are different variations, but that's, I think, the easiest one or the most basic one to stick with. All right? Questions on any of this? Homework? Quiz tomorrow? And then we actually are going to start chapter 7 tomorrow, too.